So we're going to start with Steve Liu and Raj Shah from the city of Houston. So come on up and you're on.
Go up there. Good morning, everybody. Well, I guess I should have offered a free buffet outside to get more people here, but then I was told that that's private, you can't do that. Anyway, my name is Rasha, and our managing engineer Steve Liu is the main speaker actually, you know. And we're going to start with this, and you can read the title. It's a view from above and below. Using the drone, we started this project many years back. We were one of the first one. Get the clicker.
It should be up.
Thanks. Look at the view of city of Houston. Fantastic view. This was taken by UAV about 2 years back, and I'm sure there's some changes in that. And you should also see this view. This is another angle. This is a land bridge award that we won last year from APWA. And that's, you can see in the middle of that, that was also, we took it from the UAV. Now going back to this one, I want to say about that, this is 650 square miles of footprint that of the infrastructure that we manage as a city of Houston. And this is also a very recent image, as I mentioned earlier. In a little while, I'm going to hand it over to Steve Liu. He will talk about street and bridge. He's over the street and bridge. Our main big boss is over here, our chief operating officer. He has to leave. I know he has a flight, but we appreciate him encouraging us to share our data, our project with other cities and other states. And that's what we do actually. And that helps us coming out with a new technology. And before I hand it over to Steve, I want to say something about Steve first. He's one of those guys, he's over street and bridge, but I can tell you one thing. If GPS ever gets lost in Houston, if they cannot find the street, they call Steve. He's that much familiar about the streets as well as bridge. So, and this is the purpose we follow. So this is our fundamental deal about purpose. We call it rocket, and I'll have Steve explain all the detail. And then Steve, all yours.
Okay, thank you, Raj. Thank you for having us here. We're very excited. My name is Steve Liu. I'm a managing engineer in Houston Public Works, and I work on the operation and maintenance of the street, mainly the pavement and the bridges in support of public works operations. And so as Raj mentioned, our 5 to Thrive values are rocket, respect, ownership, communication, integrity, and teamwork. Those are the values that we live by and work by to create a strong foundation for Houston to thrive, which is very, very critical. The learning objectives that we wanted to share today are, number one, to understand and identify potential uses of UAV technology for municipalities. And then also to understand how to develop and prepare asset management rating criteria to evaluate infrastructure conditions from data collected by UAVs when it's applicable, when we can do that. Additionally, understanding how to leverage mapping technology and implement new strategies to improve safety by reducing the boots on the ground demand that a lot of agencies do encounter. Houston Public Works is huge. Just for example, we have 16,000 lane miles of streets, thousands of miles of storm drains and ditches. We've got nearly 1,400 bridges and a lot of off-road drainage channels. Challenges, just as a picture that just gives you some ideas of a bridge example in a different area. Challenges for our bridges, our channels. For example, some of them are very hard to reach assets. In a limited eliminating safety risks for personnel and equipment are critical in trying to get to those locations, those assets, and trying to accelerate assessment completion rates and finding cost-effective alternatives, and just ensuring that Houston Public Works is up to date with technology and using technology. So UAV emerged as a solution, providing those additional features up there, and there really were areas where we could find areas to improve. And we'll go over some of those specific cases, primarily on the bridges and the stormwater assets, where they're difficult to get to. We did do some additional work on drinking water systems, assets, wastewater systems, and we even had the capacity for emergency response in there if needed. So that was something that was discussed and put in our contract. We had basically developed a multi-year contract with drone services, contracted that out through a request for proposals, and got that all secured and awarded with a contractor that helps provide this. So we contract this out. We don't own the drones, the UAVs. So going into really our first case areas is in the bridges, and there's some history into why this really started off with the bridges. We had two of our longest bridges in Houston are the Westlake Houston Parkway bridges. They're almost a mile long. They're about 4,300 feet long, and they're one of the few roads that lead into the Kingwood major subdivision. And we've had problems over the years with the elastomeric bearing pads. The bridge beams sit on those heavy-duty rubber pads, elastomeric bearing pads. They're extremely highly engineered pads. They can't be too soft, or the beams will mush into them, and they can't be too stiff, or they won't move. So a bridge engineer designs those elastomeric bearing pads to move back and forth with the thermal expansion and contraction. They can be prone to walking out, and then the beams drop and hit the bends. And we've had that happen before. It's had us, have to close down lanes on the bridges while we repair them. But what I noticed one year was we had a rehab project on the bridges, and we fixed a number of, it was dozens of elastomeric pads on the bridge. And then about 3 years later, their beam set dropped, and we had to shut down the lanes, put out the traffic control. And so it caused me to question, didn't we just do this about 3 years ago? Why are we doing this again? What's going on out there? And so I started asking some questions, and found out that those bridges have decks that are 400 feet long. We wouldn't build a bridge like that anymore. So, I asked, well, can you cut the decks in half so they don't move so much? No, you can't cut the decks. We're basically stuck with the 400-foot spans on the bridge, indefinitely. It's just the way they were built. We wouldn't do it anymore. We wouldn't do a new bridge. But this is what we got. We have to maintain the asset as best we can. And so monitoring really was the thought that came to mind was, well, let's check up on these pads that seem to be walking out. Let's try to anticipate and catch these before, so we can plan the rehab to where we don't shut down major lanes to a major subdivision community out there in the Houston, city of Houston. So that was one of them, and that's when Raj and I happened to be talking about it, and we started assembling that contract to address that, and then also canvass the other operators in public works, water, wastewater, stormwater. And as we know, we'll go into that, the stormwater assets can be really difficult to access as well. So improving time and being able to fly the UAVs under these bridges was very, very helpful. So cuts down on a lot of different things, access, traffic control, not affecting the traveling of the public, and they can prepare reports and videos, pictures for us very nicely, and it really helps. So the boots on the ground, comparison of inspected bridges. This is just a sample of a different type of bridge. We have quite a wide assortment of bridge types, and some of them are very high. The Main Street Bridge over Buffalo Bayou is a concrete spandrel arch bridge. It's really tall. This is not it, but we have ones that are very tall. We have ones that are very low. So wide variety. Using snooper trucks, things like that can be very involved. Getting different types of equipment, and just walking under the bridges or getting boats. And there's really limitations to what can be seen. This is the Sabine Street Bridge over Buffalo Bayou. It's probably one of the most walked bridges in Houston, just outside of the west side of downtown. It's basically about 100 years old. I think it was built in 1924. And so we had this bridge flowing. And what we did, we're on it's about our third or fourth year of flying the bridges. And so for the first year, we did those two longest bridges. Then we went to Buffalo Bayou, and we flew from downstream going upstream, capturing as many as we could within funding limitations. And then the third year, we did White Oak Bayou from downstream to upstream as far as we could go. And White Oak Bayou flows into Buffalo Bayou. And then our additional year, we'll go ahead and go back and check on those Westlake Houston bridges. So this gives you a tally, and we have about 70 plus bridges that we've flown out of our 1,400 bridges. We probably wouldn't, it's about 1,000 that are over 20-foot bridges that the state inspects under the federal program. So those are really the kind of the key ones. We're not going to fly the shorter ones that are not a risk issue or of a concern. This is just some example pictures under the Westlake Houston Parkway bridges. Like I said, those bridges are 4,300 feet long. Quite a bit of the bridge, a third or half of it has water, the San Jacinto River under it. The other 2/3, it's either underwater if it's flowing, or it's like mush under there with sandbars, mud bars, and a lot of vegetation. It's very hard to access down under there and look at all those different beams that are there. So you can pick up different things that might show up out there, and at least be able to use this as a visual aid. That was the goal with this. It wasn't to provide a detailed structural engineering report that would possibly. We didn't want a report that might have any type of a conflict with the state's BRINSAC reports. So we don't expect the drone operator, the pilots, they're experts in flying it around here safely, to be structural engineers. We view the bridges as the extra set of eyes to bring that data carefully and closely up, because it's difficult for the engineers to actually get up under these bridges under could be hundreds and hundreds of beams. In the Houston heat, humidity, with all the mosquitoes and critters everywhere. Looking at these for hours and hours and days. So having that access is really important to be able to look at those. These are just some more close-ups of under the Westlake Houston Parkway bridges. Lots of vegetation. We in Houston, probably like a lot of agencies, the access on the four corners of the bridges are very difficult. A lot of times we don't have bridge access easements on the four corners of the bridge to even drive vehicles down there. So, you know, cutting brush, trying to lower people down there, find trails, you know, openings. I mean, some of them are more accessible than others, but some of them they're kind of a project just to get the access to go down there safely and avoid the snakes and things like that. Okay, so yeah, here's another example, an overhead view, and the angles of the UAVs are really nice. You know, you can get these overhead views, you can get the side views, you can get the below views. Really enhances the opportunity to see things. And then when we give these videos and pictures to our bridge structural engineer, he can sit down and review these in the office and determine, do we need a follow-up? Do we need to go back and look at a specific place? Because that confirmation is important to confirm that it's okay. We don't have an imminent issue going on, but we can spot something if it's out there. This is an example. Apologize for the purple coloration on there, but the red circles are showing how close up the UAV can get to spotting concrete spalls on the bridges. Once again, some of these they're really difficult to access. And with Houston's got a lot of tree canopies down there, so it's kind of dark under some of the bridges. There's not a whole lot of sunlight in some spots, so that can be an issue. This is a picture of the drone flying around with the lights on it, because we asked them to consider putting lights on it so you can fly up and see the shadowy areas under there, because of course Houston, with all the moisture and humidity, stuff grows, whether it's green or black colored on just about any surface out there. So getting up under there to see the shadowing and the things that grow on their structures. But you can see all the trees around there too on the edges. There's not a lot of real good access easements on the corner, so you don't want to miss things. So it's helpful to really comprehensively. And I've noticed that the pilots, companies, they're very conscientious. They fly over the bridges very carefully and pick up a large amount of the surface area. There's a close up with the lights on it there and looking up under the bridge. Okay, so when we compare some of this, to the boots on the ground. What we found was with the drones, they would fly the bridges in about a 50-minute average flight time, capturing each bridge. Maybe 3 hours to process the data analysis and issue a report to us. So it's really very, very efficient to have that. The second really large case study area that we wanted to share was the stormwater open drainage systems, the channels. With these, we could do a comparison also of field crews versus the UAV, and some of it's pretty obvious. When you got to go out and walk channels, put on mosquito-type shirts, mosquito spray, bring your water bottles. All those things have a snake stick. It's difficult. I've walked a lot of Harris County flood control channels and City of Houston flood control channels, and they're quite an effort. It's nice to go in the winter when the vegetation's brown, but when it's grown, it really is a major chore. So we save time, we save equipment hazards, access, and the time to get the report is very reasonable. This is a picture right here of one of the off-road channels that was flowing, and it provides a really nice map. There's a little legend over there that they detail the different things that they found out there. Now, unlike the bridges where we didn't provide a a structural report or a specific thing. It's more of a visual inspection. With the off-road channels, we actually did have a condition rating index over here, good, fair, poor, not applicable, and then we had defect types there and some annotations. So the stormwater operations team could actually review this here and determine what else that they need. This is the inspection. This is similar, the same picture over there of the channel, but this table here is called the inspection results. So it'll have the code, the description of the result, and then the field comments like culverts, look clear of debris and allow water to flow freely. So that confirmation is good. You go focus on where do you have a problem. There's a mechanical silt removal needed. Major erosion condition is the bottom note there. So you'll see different comments there that are very helpful. This is more imagery from flying the off-road channels there. Different vegetation types. Some more channels there. The one on the lower right-hand side that is actually a little boat that flipped over that they found out in the channel. So there's just all kinds of objects that can be in these channels, all over the place. And people just don't go out there. It's out of the sight, out of the way. Just with big shrubs, big trees, and people don't see it. But when that boat floats down, if it covers a culvert opening and plugs that culvert, we can have a major drainage problem. So it's important to maintain and operate and find these things. This is more examples of off-road channels with debris that's fallen trees, other types of debris in the channels. And now we know where it's at. We've got coordinates on it. We can schedule a work order and get out there and find these trouble spots and be more pinpoint in the repairs rather than trying to just issue a big global rehab to go work on the channel. So it helps target. This is one of our favorite pictures of an outfall that's collapsed. And this shows the right here. This is where the outfall basically collapsed out here into the flood control channel, the city drainage channel, and that definitely needs to be repaired there before it starts progressing and eroding back up towards these structures here. So that was a real good catch with the data. And once again, we have a parallel amount of time right there, with the savings and the processing and collecting the data there. Okay, with that, I'm going to turn it back over to Raj Shaw, since Raj has been just tremendous at putting together the overall contract, administering it, and bringing the technology, and knowing how to put it all together. So, Raj.
Anyway, basically, we do not buy any hardware. When we started this project, our intention was to just come up with a scope of work, and we set it up for all the assets that we can find with City of Houston that we need to manage. So we put together RFP where we only publish our scope. You use your method and means to collect the data and deliver it. And that's what we have done over the years, the last 3.5 years. I'm a believer of buying hardware at the end of the project than the beginning of the project. I learned that hardware when I started with IT many years back. You buy the heavy computer and then you realize the system you purchased doesn't work for the hardware that you purchased 3 years back. So learning from that experience, that's how we publish it. Our RFP, we hired the contractor and they came and did the proof of concept and came up with we selected one of the main contractor and handed over the project to them. Anyway, on that note, basically what we do is we provide you GIS data. We provide you the file. You do whatever is needed, whether you have to go and inform the community, you have to put the little thing on your doorknob at all the household, that is a job of the contractor, not ours. And we only on the receiving end of the data. Now, if you look at here, what type of data you collect? Just like in IT, when you buy some system, you want to make sure that the format they give it to you is usable. You don't want to buy something that is not, you cannot use, other group cannot use, other department cannot use it. So we did the research that time, and he said, okay, this is the format we need. You use your drone, whether you use any type of drone, Chinese, Australian, Switzerland, or United States. As long as you deliver us the format that we need, that's all we get. And then for mapping, we used, at that time, we used a pitch 40 because that was, in my opinion, was it from Switzerland, was it 3D. And then over the year, we started using ASIS platform SideScan. That's where we store the data. And another thing was delivery of the data. When you get the images and the video that they give you from UAV, how do you receive it? That's very important because it's tons of data. So the best way we came up with the idea is I said, okay, we set up the SharePoint. Any of you, I'm sure a lot of people are familiar with the SharePoint. So we set up an external site and an internal site. We give external site to the contractor, they drop all the data over the video images, and then we bring it in for our people. Steve decides which engineer, bridge engineer gets access to that, full access to that, or the storm people decide who gets access to the storm data, and we give them access as per the role. And this is how we compare it also. This is what we tell the contractor, that they have to have all three check marks on the right side, and we're done. That's their responsibility. As you can see that they must have their own certified UAV operators, UAV equipment, must have process in place, flight planning. They can use their flight plan, they can store the flight plan, they can recycle the flight plan. We are out of all that. They can use any drones of their choice, as long as we get the data what we need. Again, liability also, you can see the check mark on the right side. These are all from UAV contractor. Now, this is what we have learned. You can really mistake. The technology is always there to improve. You accept new technology, new hardware. Now we saw all this show over here, UAV show. Look at if you have seen the drones 7-8 years back, and now, look at the difference. We went to a couple of conferences, major national conference. I went there, I go every year. So 7 years back, I went to one of the major conferences of public works. They did not even have a word UAV in the conference. I'm the one who complained there. I said, the whole world is going towards UAV, and you guys do not have any presentation of that. And now, if you look at from starting with the first drone, not the toy one that you buy at some computer store, I'm talking about the real one. And now, yesterday, I was chief operating officer and Steve, we went into the show. Amazing. We also went to that flying demo over there. Amazing. Look at the amount of time and people put them into that. So if the technology is moving that fast, best thing to do is now jump on it. In my opinion, that so far, in my opinion, the UAV, we ain't seen nothing yet. We are miles away from what we have to see about the drone. Now, on that note, I'm just gonna switch. I know we are already over time, way over time, but she said, go ahead, we'll be here till 1:30. Okay, now, question 10. And this is beautiful. I want to know if you can raise any question that we need to know. We like to put them on the next scope that we are working on it. What else would you suggest from this? We talked about all these assets, and I know Steve comes up with so many ways to look at this stroke. We're going to line up all that, but I want to hear from the audience that, hey, you're the public works. Put that on your scope, so next time the drone people come in, the people who actually manufacture the drone or fly, they will come to you and say, this we cannot do, or this we will definitely do it. You'll put the minimum, without putting minimum goods on the ground, safety in the place, everything. So I like to have that question. And after that questions from you actually, see, Steve cannot answer that question. All right? But I want you to know that we are from Houston. We're the fourth largest city in the United States. If anybody from here, from Chicago, watch out. We are soon to be the third largest city in the United States. Technology is our name. That is our main game. So based on that, I always like to say this one, but this is my pop quiz test, but I was told that there's no pop quiz here. This is Las Vegas. You don't ask questions what they did there last night or today. This is Las Vegas, so we won't ask you that pop quiz. All right, we wait for the questions now.
Go ahead.
When you put out your RFP, just ballpark, how many responses did you get? And then how did you choose ultimately? Was it based on budget or time they could get the project done? And then follow up to that, how often do you renew that contract or put out another RFP?
Totally, we got 7 responses. Out of that, 4 of them we put top of the list. And our rule is always, I've been in Nolan City for 19 years. I'm enrolled in 12 RFP. My first rule of thumb, when I get enrolled, I said, we want to do proof of concept. You can bring the best equipment out there, but if that equipment doesn't do what we are looking for it, we're not going to pay you after you sell it. You know, you sell us any hardware that works today. The deal was the scope. So we look for the proof of concept. What do they call it also? The second word for the proof.
But we did like a short list and then a field demo to make sure that each of the proposal of the vendors, service providers, could actually do what they were saying in the written proposals.
Okay.
And so we verified it, and then after that, in the procurement, the request for proposals, we showed the evaluation criteria, and I think we weighted that like 2/3, and then we weighted, I think, price like a third. There was some sort of a formula that we had in there, and we had a group that evaluated.
Like we have a group of people that study everyone's response. And by the way, to answer the other question, yes, we do consider budget. We work with city. You know.
So we follow the city's procurement process for an RFP.
And then that contract is a certain amount of time, and then you put out another RFP, or?
Yes.
Okay.
It's a 3+2. So 3 years and then 2 years extension. After 5 years, we have to go again with the open bid.
Gotcha.
So that's going to be in 26 if you decide to bid.
Thank you.
So you're gathering a lot more data through these drones, and these service providers are providing you, turning over that data to you. On your side, have you hired more people to go through that data? How has that affected the amount of data that you have coming in? How has that affected, kind of your personnel and what they're doing with it, or how they're working with that data?
Yeah, it's affected each of the operating, since we're really quite large. The water people would have to evaluate their water data. The wastewater people have to evaluate their wastewater data. The stormwater people are evaluating their data, and the bridge people are evaluating our data. So it's a bit different for each operator, asset owner. I don't think that anybody hired extra people for that, but they took existing staff. I know we did on the bridges. We took existing staff to go through as much of the data as they could within a certain time period. and have it there. If they weren't able to go through it, then it's there as a file, as a reference in case a problem came up. So, yeah, we didn't have, like these FTEs, we weren't able to hire additional people. Yes, go ahead.
What is the cost per mission? Compared to things?
Yeah, what's the cost?
You're talking about doing boots on the ground as well, using the UAV. We found out, if I remember right, it's 1:9 ratio. So every 9 hours it takes to put boots on the ground compared to 1 hour using drone. It could have been changed now, because of the new technology on the drones and all that. Our information is about 2-year-old. Plus, yesterday I attended one seminar here. I think they were talking about shutting down the bridge nowadays costs $6,000 every hour. Yeah,
That was Caltrans.
Yeah.
Instead of one lane closure or something, was like $6,000 per their rough numbers. So, yeah, there's definitely some costs. You try to quantify some of it, but, some of it is probably a little bit tricky to actually, quantify every single aspect of the cost, and accessing actually those views. There's a lot of value in the views in detecting the defects early rather than when it's an emergency. If you think about that cost of shutting down lanes, all the inconvenience, just finding a problem in advance is very valuable. So, so that's a part of it. We had like I think it was a little cost schedule, a rough in there of what we would charge for different sized bridges, roughly.
Gentlemen, go ahead, please.
I just wondered what portion of the work that used to be done by field crews with manual inspection is now done by drones, and whether you plan on increasing that so that the majority is done by drones and drone crews.
Well, on the bridges, I would say it's additional information because we still do, the state inspects our longer bridges every 2 years, and they deliver a structural signed and sealed engineering report. We still get those reports from the state under the federal program, every year. They're very detailed bridge structural investigations. We still do our maintenance inspections with our maintenance staff every 6 months on every bridge, to go do a non-structural maintenance inspection, determine what's out there, guardrails, hid, vegetation. It parallels our cut and cleans every 6 months on every bridge. And then we have an in-house structural engineer that checks the shorter bridges every 2 years. So we haven't reduced it, we've added this in addition to place extra eyes on the bridges. So it's something additional that we've added. We saw a need for it because there are things that they're harder to see, and we wanted extra eyes in more locations.
All right, and I think we'll wrap it up there we can maybe have more questions at the end for everybody.
Thank you very much.
We always prepare for an hour.
Oh, yeah.
Thank you very much, appreciate it.
Yeah, lots of valuable information shared there. So next up, we're going to have Matthew Pughesmark come up and give us some more information from Orleans. Do you want to handhold or do you want to sit for 5? Either or.
Yes, you can. Hi, my name is Matt Pughesmark. I'm the Director of Products at Linux. Thanks. Many of you know our resale company, systems integrator, custom solutions, and training, BAMTech. So today I'm going to talk to you about a product that we're currently taking to market right now. We're using a variety of different technologies, including UAV, AI, and some other tooling in data science to detect the lamination of bridge decks. I'm really really pleased to be going right after the City of Houston folks here. I think I can tag on to a number of themes that they touched on here. So who is Linux and what do we do? We're largely considered a leader in the geospatial market, offering hardware, software, and training solutions, as I just described, with our partner Ramtech. Our vision is to empower communities with tools to allow for easy data collection, management, and analysis. Using these insights so that we can create a stronger, safer, and more resilient infrastructure. As I described, Ramtech assists our clients in discovering, defining, and designing geospatial solutions with a variety of technologies, resale partnerships, and other solutions over time. Our company's history goes way back. We are a part of George Butler Associates, original Georgia GBA companies today in Kansas City. We're a 23-person company sitting under GBA right now. And you can see the history of how we came up through support of our parent company, GBA, and really beginning to really see some very steady growth beginning in 2023 with a variety of solutions that I just described to you through Ramtech. I came onto the company about a year and a half ago, and really my mandate and my job is to bring this really exciting technology and what had become a number of different solutions and process and a lot of science over time, be able to package that up into a product that we can begin to take to market. And so in 2024, what we've spent our time doing is basically going into the marketplace, into the DOT marketplace, with this bridge deck delamination early adopter phase, where we would go out and do demos with the DOTs. And so I'll talk a little bit more about that here in a minute. So this just gives you an idea of some of the markets that we play in, largely focused on infrastructure and engineering marketplaces. Again, a lot of systems integration approaches with UAS, UAV, data science pipelines, geospatial. Really, again, trying to empower our customers through these custom workflows. And again, today I'm here to talk to you about the Bridge product specifically. And really, as we come into novel approaches through our product and IPA development, we're going to be working on a number of project efforts in the future that are going to be really looking at productizing solutions that can fit into the infrastructure, critical infrastructure and engineering marketplaces, leveraging this early success that we're having with our product that is focused on bridge deck delamination. So the case study is really all about the bridge deck itself. The C- grade that you see here from the civil engineering report card is an overall report for engineering infrastructure in the United States. This is in 2021, was the latest report. Bridges themselves are basically reporting about a C at this time. And so you can see there's a variety of different pieces here that require us to really look at our infrastructure and really preserving our infrastructure. So we're really trying to get ahead of the problems, just like the City of Houston just described. The key is to identify problems in a variety of structural issues around the bridge. Again, our niche focus on the bridge deck itself. So you heard a little bit about bridge inspection a few minutes ago with the City of Houston. I'm going to go into a little bit more detail here. Again, these are driving themes into where we feel like we have a really good niche in the marketplace. A bridge inspector has a variety of tools at his or her disposal. A lot of these tools are very, very cumbersome and challenging. As the City of Houston showed, having a snooper truck or a boat on the river to get under the bridge and things like that, these are very expensive and challenging pieces of equipment to use to do inspections. They can often put workers at risk and safety risks. But these are the traditional methods, and many of these are very high-tech methods, and they work very, very well. And the other place where we feel like we have a niche in this market is that ours is very affordable in the bridge deck delamination focus. Many of these other ones can come after that. So ours can be a very kind of level one approach to scanning that bridge deck, seeing if there's any issues in there. And then these other technologies that you're seeing here that are much more expensive, are also actually much more thorough in many cases, and that's fine. So these are really complementary technologies to the niche that we're applying our product to. So this product is obviously compliance driven. So federal highway requires the asset owner to inspect the bridge deck, and City of Houston went through this. I'm going to go pretty quickly through this since you heard a lot of this a minute ago. But really, when you consider the volume of work in the United States, so 617,000 bridges inspected biannually, states are really looking for a more systematic approach to that. And so a bridge inspector today, if it's a super busy bridge, it's dangerous to have a lane closure, it backs up traffic, limits commerce, puts the public at risk. That's a really challenging decision to make, to go out under that bridge deck, shut down the lane, and do what these inspectors are doing right here in these photographs, which is they're hitting the bridge deck with chains, and they're listening and feeling for the potential for delamination to be underneath that concrete surface, where water got through a crack and is begin to create problems in the bridge deck. The other thing is, having a lack of skilled, qualified individuals. So I think it's the COO from the City of Houston that we heard talk this morning. I saw Raj had his statistic up there. He said there's 4,000 employees in public works at the City of Houston. I think I heard a number, maybe even a little bit larger than that from the COO, and then he also said there's 700 vacancies within the City of Houston Public Works, which is just mind-blowing when you think about it. In bridge inspection, if you look across the states, the United States, county, cities, they're looking for inspectors. There are a lot of vacancies out there. So having skilled labor to be able to do these things, do them manually, do them in a very risky way, is a challenge. The other thing about our product is to really make it repeatable, right? So again, the drone is flying off to the side of the bridge, scanning the bridge deck throughout the day. This is a very repeatable process. This is something that you can look for defects over time. It's really hard if the inspector has to drive across the bridge, and he or she puts their thumb out like this while they drive and they do a visual inspection, because sometimes that is how it's done. In a really high traffic scenario where you can't shut down the bridge, that's a really subjective way to do it. They know that, that's okay. This makes it a very repeatable and systematic approach. So there's really a lot of new tools making their way into bridge inspection. And so there's a newish requirement. The DOTs have been aware of this for a number of years. I think it was published in 2022. There's a phase-in period of time. And that new requirement is called SNIBI. And a part of SNIBI is that bridge inspections, using a UAS in the bridge inspection can actually become a part of that. So it's actually in the code now. So it's an acceptable tool in many cases to do different types of inspections and utilize it just the way that the City of Houston described it this morning. And then the other thing is that DOTs, so the last year and a half, I've gotten to spend a lot of time as a product person out talking to DOTs. And it's really interesting to hear the stories from DOTs about the ways that they're using drones. And it was great to see how the City of Houston is using drones to do different levels of inspection, or to at least aid and assist in inspections, and to keep workers safe, and to get more detailed data. But traditionally, for about a decade or so, mainly I would say that DOTs have had a lot of experience, doing exactly what we're trying to do here, which is fly a drone, take a series of photographs, use thermal camera on the drone as well, but they only do it maybe once or twice a day. They try to come up, see what they're going to see through the heating and cooling of the deck throughout the day, and that can be a really challenging thing, and so we're trying to automate that process. So again, just to really quickly jump on the trends here, in the bridge world, I'll be in Salt Lake City at the National Bridge Preservation Conference next week, and at that conference, preservation is the key. So preservation is really the mandate out there, because as you saw, and as you see this quote here, there's really no way to build or construct our way out of this challenge that we have for maintenance. And so really the key is, and again, City of Houston did a solid job of this, which is, hey, if you can find something early, that can make a huge difference. Safety, financial, it's measurable, it's going to help you make predictions into the future. There's so many different opportunities here for utilizing this way of doing inspection. So again, the niche of our product is to really focus on the bridge deck itself. So the bridge deck, the roof of the bridge, right? Water cracks, the lamination inside the deck, water and other things get in there. It's really hard to see that over time with the naked eye. These technologies are helping us reveal that. Our process largely uses statistical analysis and computer vision technologies to detect defects in this thermographic imaging. This is a bridge deck here in central Washington State in Chelan County that we scanned just a couple of weeks ago. So really the game changer for us this last year was the release of the dock technologies. This autonomous opportunity for us with robotics really helped us begin to hone in on what we might be able to do to get costs down to do the actual inspection. This is just a shot here of our team. So this is a mixture of data scientists, 107 pilots, other folks from the MAMTech side of our business that know these technologies inside and out. On the right side of the screen here was the ability to create a flight plan ahead of time, so you have your game plan all ready to go. That's all programmed into the dock and into our software. In this particular case here, we were able to capture 5 bridge decks in one day through scans. So, basically within a day's time, from sun up till sundown, depending on the size of the bridge deck, battery life on the drone, ability to recharge and things like that in the field, we were able to capture in this particular instance 5 bridge decks in one day. So let me dive a little bit deeper now into Decker, our solution that we're bringing into the marketplace. Really what we're trying to do is simplify and automate the process. What we're trying to boil everything down to, because I can understand the challenges of having all that data. So the way what City of Houston described, it's just, and we had a number of questions from the audience around this, those are just mountains of data, right? In this particular case, in this specific product niche, we're trying to just boil that down to the answer that meets the compliance that's needed in this particular case. And so really having the autonomous solution here, so you see this little 4x8 trailer here with the dock mounted on it, gas power generator, electric car battery, solar panel, leveling jacks. The idea here from the autonomous part of it is to set it and forget it for the day. Of course, we've got through our demo phases, we have a pilot out there all day long observing this. We have the DOTs coming out there learning this process with us, seeing how automated it is, and it's really been a game changer. So again, that automated data collection is really a key here, just to make it really, really easy and make it really, really affordable and be attractive to the DOT to be able to bring this into their Swiss Army knife of inspection tools that they have. The next set of this is our software. So our proprietary software includes proprietary flight planner, way to ingest the data goes up into the cloud. The data immediately starts getting processed through our data science pipeline, through our computer vision and AI pipeline, and at the end of this, you get a really detailed report showing you a variety of different aspects of the bridge deck that you might be concerned on. It basically creates the treasure map, right? So this is your level 1 inspection. Do not send people out into the deck. Do not shut down that bridge to traffic. Basically be able to do this in a very automated way and basically get your answer in your treasure map at each waypoint along that bridge that tells you that, yeah, there might be an issue right here and you should maybe go check that out, or yeah, this doesn't look like it's much of an issue and it actually really gets close to matching what we typically rated it. But again, this is a very systematic approach. This is not a subjective approach. And so as the bridge heats up and cools down throughout the day, when you go out there again in a couple of years and you do it again, you might see some of those defects beginning to expand. And then again, that gives you the opportunity to be able to expand on that, go out there and do another level of inspection. And then the other piece is just having that API deliverable. So basically like having that come into your asset management system, be able to report that as the asset owner, being able to report that to the federal highway for your compliance there. Really trying to make this a really seamless simple processes. You can see this is automated all the way from start to finish. We often like to call this product a solution as a service, since it's including this trailer system with the dock, all the way through the data science, AI, computer vision, and physics pipeline, all the way into these deliverables that are really simple for the inspector to utilize and understand. So I wanted to talk just for a second about the really exciting thing that happened this year, which is our early adopter phase. So I think we're somewhere around having 70 bridge decks across the nation captured through our early adopter process. So this, is our opportunity to really get to know these customers, do a lot of outreach. Obviously, we're based in Kansas City metro area, so we have a lot of relationships in the middle of the country. So we utilized those, did demos with all of those customers there. We were up in Washington State because we wanted to partner with somebody that wasn't a state DOT as well. This was a county association that works together to advance UAS technologies within county public works agencies. So we spent time up in Washington State. We were just right next door here up in Reno, the California border, about a month and a half ago, spanning some very busy bridge decks there. Traffic load of 70,000 vehicles a day going over those decks. And then we've had a long-standing early adopter phase with New Mexico over the last 6 months as well. Actually, this week we were up in New York State, near Buffalo, New York. Really challenging weather conditions up there, but we had 3 successful days of bridge deck collection there. So this is showing you just a snippet of what the products are related to this. And so at the top level here, you're seeing basically the treasure map. So this is your final contour map of the bridge deck where there may have the potential for delamination occurring. And again, in most cases, when you're hanging out with the inspector and you start to look at these reports, these treasure maps together with the inspector, it's a really eye-opening process for them to be able to utilize this and see it. And sometimes they'll say things like, wow, that's exactly what I thought might be going on there. It's going to be really interesting to inspect this deck again with this technology in a couple of years. Or someone will say, wow, this is really interesting. I always wondered about the approach to that bridge deck and how when a big semi-truck hits that approach and then it bounces onto the deck, some of the damage that it might be doing there, this technology is really helping me see that. So the customer use cases and the other stories related to that are just beginning, and I know there's going to be a lot of other approaches that we can take in the future to continue to iterate on this and improve it over time. And then in addition to that, we've got some deep learning models and machine learning going on the bottom screen here, where we're starting to do some predictive analytics and feed a variety of different physics models to be able to produce some other simulated results as well, which is really exciting. So again, what we're trying to do here is automate this entire platform from a solution as a service all the way from beginning to end. Just lease this trailer, tow it out next to the bridge deck for the day, have a pilot babysit it, go from sun up till sundown, or generally the heating and cooling of the bridge deck. Do this every couple of years and basically get your delaminated report. A statistical average here is what I'm showing on this screen for the report, which is kind of a level of confidence that we have in the report that comes out. And again, this is a really compelling thing where you can kind of turn up the intensity up and down for what the thermal camera is seeing in the bridge deck to be able to kind of customize your report as well. So we'll have a whole bunch of other tools along the way in our roadmap into the future as well. Right, any questions?
All right, thank you, Ben.
Awesome.
All right, our final speaker in the session is going to be Don Seals from Truck Design Group. So come on up.
All right, we'll make this short and sweet, because I think everybody wants to get back to their gambling or food or catching airplanes. Following on the back of the first two speakers, the first people got up here and talked about from the actual asset owner side of it, and then the next person came up and they talked about using new technology and how they're developing it and to make all these these inspections easier. And I'm gonna follow it up with what it is we actually do as a service provider. Big and small jobs for DOTs is what I'm specifically gonna talk about today. So I work for Trek Design Group. It's a 22-year-old company. It's a woman-owned business based out of Kansas City with offices in St. Louis, Memphis, Nebraska, Arkansas. The idea behind Trek is to become the technology leader in the Midwest by 2027. So we do full service engineering and survey. And today we have a leader of our survey and a couple pilots that have been here. And we have a booth, which we'll name later. I'm Don Seals. I am the one in charge of all the LiDAR. I have an extensive career in LiDAR, from tripod scanning to thousands of dimension measuring. I've joked all week, my claim to fame is the sphere, working on it, and working with DOTs on building bridges using that, and then got into mobile and UAV and combining all those all over the U.S. Last year, Trek Design Group went everywhere from Delaware to Hawaii doing these types of projects for DOTs. So it doesn't matter which project you're doing, whether it's a rural bridge that's like 3,000 foot long, and that's all we're doing, or in the case of the bottom right one, Buck O'Neill Bridge, which I talk about in other conferences, you'll see at the end. It was a very complex job. There's 25 different asset owners that do it. There was 500 crashes on the bridge a year, and it needed to be replaced. It's one of the oldest thoroughfares to go north out of Kansas City. As you see in the picture on the right, it's right next to an airport, which has its own challenges for flying AUVs. And so every time there's where is it located, what is the safety concerns, and what are the budgets, right? Because that's where will determine, just like the guys from Houston said, that determines what really happens. And I think that's where the other guys, Alex, said, they're trying to improve that so it makes it more cost beneficial to get more bridges done, because we all know, especially along the Gulf Coast area where I used to live, that some of those bridges are getting highly deteriorated, and it's very dangerous. We had the Minneapolis collapse a few years ago, things like that. We don't want that. So the location. So when we look at urban and rural, right? What do you have the problems in urban? Well, first of all, we've talked about traffic 15 times up here today, and we have that problem. You also have where can you take off from, because there's going to be cell tower sites, there's going to be high wires, there's going to be tall buildings, there's going to be airports, there's going to be no-fly zones, and everything that rural, you might have less of that. But you're also going to have things that you might not see. Like I've been down there at Bald Eagles, we went to Fly Bridge last year, and we found a nest, and if you get too close, they win, you don't, in the case of our size of drones. So you want to do that. You also need, in our case, in our company, we have somebody on staff that is, in my opinion, a guru to make sure that we can fly where we need to fly, and that will, as we can talk later, will affect your budget. If you plan on flying 280 or 320 feet, and now you're flying at 180 feet, and to get the overlap in the time that it consumes. The other thing with the location is and these guys beat that dead horse too, is the amount of traffic during the day. Like there's a lot of traffic at a certain time. You obviously don't fly, but also the sun's the issue, so you want to make sure you're flying at the optimum times. So safety, you need to also know, in the case of Buck O'Neill, there's a cliff there. So you want to make sure you're operating your drone safely, and if you're going to be higher in an elevation than where you took off, that you've taken that into consideration. You've had that in your flight plans. We have a two-step process. Somebody creates the flight plan, and another person looks at the flight plan, and we try to do that. The railroads are always in consideration. They love their spot. They want you to be on their spot. If you don't want to do that, because that's right there. this video into that, but it also adds all the tree and brush cover and things like that. So you need to really look at where can I put my control, and this, sometimes you can't go on the opposite side of the railroad without their permission, so you're not gonna be able to place your area control in a great manner to give you the optimal results for all of your flights and stitching all your photos together. That's where the budget comes in, because all the things I just spoke about were just what has to happen that relates to the field time and the office time. What the Houston Public Works is doing is a little bit different than what we do. We are creating engineering drawings at the end. We're creating full surveys. And in those, you're gonna have to have people go out and set ground control. And from that ground control, we will set aerial targets, you see there, and they need to be placed in a correct geometrical shape, and they need to be the size that fits whatever piece of equipment you're using, and it's repeatable, right? So when we are going out on these jobs and we're looking at, okay, how long does it actually take to do it? Did you factor in the weather where we're going? Because not our jobs are in Kansas City. They're all over the state of Missouri, and every state that touches it, like I said, many other states. So we have to look at the 10-day forecast and decide we're going out there. Did you budget and did you put in yours? Hey, we get out there and it's raining for 3 days, or the wind is 20 miles an hour. You're not going to collect data when you're sitting around. Or in the case of a recent project where we did 2,700 acres or thereabouts of 9 miles of state right-of-way, as we were flying, it took us 6-7 days to fly it. And we were hampered by, in the morning, going one way, you're not going to get the correct amount on the pavement because of the amount of traffic. And at 3:30, it was back again. So you had a very short window to do it in. And if you factor the weather in, if the wind's picked up in the middle of the day, you can cut it shorter. So, and the FAA, the approval process, it used to be we were getting some of ours in like a day or two. Now we're experiencing maybe 2 to 3 weeks, depending where you want to fly and how close you're getting to it. So the budget will be directly proportional to the amount of time that you're out doing it, no different than a normal survey, but you're adding in factors that you might not even know till you get out there. And the people that own the land and the people beside you, they're all going to factor in, because people unfortunately don't want drones flying over. I thought you had the Houston guys had a very good picture with the people out there saying they're on the back that they were FAA approved drone pilots, right? That's a good way for people to come up and know what you're doing without going to every single person. So why should you do it, right? At the end of the day, why would you do it? The answer is the benefits. There's many things you can extrapolate from this data. You can get the digital photos that they talk about. You can look at way more surrounding area generally. You can get survey grade if you do it from the beginning. You can get the survey grade accuracy. You can get points. You can get images, and you can utilize all that to create things like this. This is the Buckle Mule Bridge in this case, we did a little bit more than flying it. We flew the entire area. We drove the entire area with a mobile unit. We used SLAM in the area. In the top left, you're going to see the tunnel come through. And then we combined all that data for the DOTs to make the proper decision of how to route the traffic when they decided to start the constructing of the bridge, which is happening as we speak, and tear down the bridge and all the utilities that would be involved. And these photos that we got from our aerial really made a huge difference as far as all the paint marks and all the utilities that we had to discover that might not have got collected ground survey in a few weeks. We did this in days. So if you want to know more about DOTs or any of the other stuff, we do have a booth here. We are talking about it. But that's what I have for you today.
I have questions. Does anybody else have questions? In integrating those different platforms together, how did you guys learn to, get the SLAM together with the ground, with the UAV aerial? Did you hit any stumbling blocks there? Is that just something you kind of evolved and figured out over time? Because I know a lot of people right now are looking to do that and don't know how.
Okay, so the most complex thing is taking, we happen to fly a DJI drone with a L2 sensor in it, and we use Trimble SX10s, and we use Leica RTC 360s, and we use SLAM that's now owned by Faro and a few other products, right? They all don't come out and go into other systems easily. So you have to find out first what format can you get it, especially in this case, we do the bulk of our extraction in microstation. So can it get into the microstation format that we want, which is generate LAS? And so I can talk about some of our workflow, which is we get all the point clouds out of Leica, out of our L2 sensor, out of our mobile sensor, and we drop it in Terrasound. And you have to make sure that sometimes they want to come out meters, and then the guy has to go ahead and convert them. So it's not seamless. Even though you're telling it to come out in one format, it doesn't always do that. So you definitely have to have polished people that work with those. But once you get them in there, I explained it to some other guys at the conference this week. I was like, look, it sounds really good and really easy to the first time you go do it, right? And then as you're combining it, you notice little inconsistencies, because which one is more accurate? And if you ask me, I think the SX10 and the RTC 360 are at one level. I think our mobile's at one level, and I think our aerials are probably the same level. And when you combine those, you're expecting to lay just flat on top of each other, and that's not really true. But that's why you had control points in all of those methods. You could say, I got it down as far as I could. And so whatever gap you might see is within the tolerance of the entire project.
Any additional questions?
I just want to thank you, noticing our flag with the on the back.
Yeah.
Thank you.
All right. Well, thank you to all of our presenters today. If you guys have any questions for them, they're still here in the front too, and find them on the floor. But thank you to everyone for showcasing those case studies and the insights there. So I will let you all go back to lunch. So thank you. Thanks, everyone.